Alright, afternoon guys. Actually, I guess maybe it's probably evening, but we're going to talk about functions, function notation, and evaluating functions today. There's not a lot that's new here, but there is enough that's new that you really need to make sure you pay attention and take really good notes. So functions can be described by equations. We've done it all along. Every time we write an equation, as long as it meets the definition of a function, it's been a function. But we can also write it as a function using what's called function notation, which looks like this. And that is pronounced f of x, because what it means is that I have a function of x, which means I have something that depends on x. This f of x is the same thing as y. And so it's just another way to say y equals, but f of x becomes very, very handy and very, very important when you get into some upper level maths. It's also very important when you are looking at graphs, so it is a notation you need to be familiar with. The input for any function is just the x values. So the input is the x values are what you put in. You can also say that it is the independent variable. The output is the y values, or what f of x equals. Okay? You could also say that it's the dependent variable. So let's do an example really quick. In this table right here, I have an equation. F of x equals 4x minus 3. That is the same thing as saying y equals 4x minus 3. They mean exactly the same thing. My input for this equation is going to be the x values. In this case, I want x to be 6, and here's how I'm going to represent that I want x to be 6. I'm going to say I want to find f of 6, what I've done is I've replaced the x with the 6. So that means that in this part of the equation, I get to replace the x with a 6. And then I just get to do the calculations. Well, 4 times 6 is 24, minus 3 is 21. So f of 6 equals 21. So that means my output, or my y values, is 21, because f of x is the exact same thing as y. They mean the same thing. So my input is what goes in, my output is what I get back out. So let's look at a couple more. So in order to find f of x, all we have to do is substitute, just like you saw. We substitute the value of x into the equation everywhere that you see an x. For example, we want to evaluate f of x equals 4x minus 3 whenever my domain is negative 1, 0, and 2. Now, if you'll remember, domain is all of your x values. So they want me to do this 3 times, when x is negative 1, when it is 0, and when it is 2. So if I wanted to find f of negative 1, I would replace this x with negative 1, and I would just simply do the math. So 4 times negative 1 is negative 4, minus 3 is negative 7. So f of negative 1 equals negative 7. What that means is this function's value at negative 1 is negative 7, and you'll see what that means graphically in just a second. But this also tells me that my range for this function is, one of the values is negative 7. So let's do one more. Let's find f of 0. You do the same thing. Replace your x with the 0 and do the math. 4 times 0 is 0, minus 3 is negative 3. So this function value at 0 is negative 3. So my domain is 0, my range is negative 3. That gives me an ordered pair that I can plot on a graph. And so here's what I mean by the graph. So I have this pretty little graph right here with this funky little line. The first question says, what is the value of f of 8? What that means is I'm trying to find, this is the same thing, you know, f of x. And so what I've done is replaced x with 8. So I want to know what this equals when x is 8. Well, x equals 8 right here. Well, the value of that graph, the y value of that graph when x equals 8 is 0, because it's right here on the x-axis. So that point, when x equals 8, y equals 0. That's all they're asking. So the next one, they want the value of f of 16. Well, right here, when x is 16, there's where my graph is at x equals 16. So if I go over here to the y-axis, y equals 12. So when they're asking this, they're basically saying, what does y equal when x is 16? And all you have to do is look at the graph and use the graph to answer. Part C says, for what value or values, which means I could have more than one answer, of x does f of x equal 4? So now they're telling you, they're giving you f of x. So they're saying y equals 4. So y equals 4 all along this line right here. And I'm going to change colors so that you can see it's different than the two I just did before. Right here, y equals 4. Well, there the graph meets y equals 4. And here the graph meets y equals 4. What they're looking for here is what values of x is that? Well, this x value right here is 4. And this x value right here is 12. So f of x equals 4 at 4 and 12. And so those are the points on the graph where y equals 4. So the same question, this time though, they say for what value or values of x does f of x equal 16? So you do the same thing. You're going to go at 16. I'm going to go across here. Well, there my graph meets 16. And here my graph means 16. So I need my x values. The x value here is going to be 18. It's right in between 16 and 20. And my x value here is 24. So my y when x is 16 is 18 and 24 because there are 2 times that this graph passes through y equals 16. So another question with the graph, you have this pretty little graph. It says for what values of x is, this should say f of x greater than or equal to 10. So I need y to be greater than or equal to 10. Well, this is 10 right here, and that's my really ugly unstraight line, but this is 10 right here. And I need to know for what values of x is this graph equal to 10 or greater than that. Okay, well, it's equal to 10 right here, which is halfway in between 14 and 16, so it starts at 15. And then it ends right here. It's still greater than or equal to 10 right there at what we call 26. So from 15 to 26, this graph is greater than or equal to 10 because it's above that line at y equals 10. So for all values of x, goes from 15 to 26 if you wanted to write it that way. But you can just say from 15 to 26 it works. Now the next question is this graph a function? This goes back to what we did on Tuesday in class. If you think about your vertical line test, you can go with your vertical line across this and you will see it never crosses through here more than once. So yes, this is a function. Passes the vertical line test is what I would say. So now let's take this a step further. It does not always have to be f of x to be considered a function. It could be g of x, h of x, any of the 26 letters of the alphabet work. So here's one that is g of x. It means the same thing. This is the same thing as saying y equals x squared minus 3x plus 2. They want us to find g of negative 2. So I've got to substitute this negative 2 everywhere I see an x squared, or an x. I want you to be very careful though. When you plug in this negative 2, this is x squared. Well, x, the whole thing is negative 2. Please place it in parentheses, not only when you write it, but also when you use your calculator, because you will get a different answer if you do not. So you plug in your negative 2's, and we'll just do the math. Well, negative 2 squared is going to be 4, and then negative 3 times negative 2 becomes positive 6 plus 2, and then when I add that up, 4 plus 6 is 10, plus 2 is 12. So this function at negative 2 equals 12. So graphically that means that when x is negative 2, y is 12. So it gives me this pretty little ordered pair. This would be the ordered pair on the graph. Pardon me. Now this one, this f of x, we're back to f of x, but you see that they're asking us to evaluate something very interesting. We want 2 times f of 3. Well, so the value that they're wanting us to plug in for x is the 3, but I have to do 2 times whatever that is. So I have to do 2 times whatever this is when I plug in the 3. So I plug in the 3 into my original equation, but I've got to make sure I multiply by 2. Now, order of operations says I got to work from the inside out. So I have 2 times. Well, 5 times 3 is 15 minus 3. And then I still have brackets. 15 minus 3 is 12. And 12 times 2 is 24. So 2 times the function at f of 3 is 24. So this means something totally different, okay? This means that my function at 3, okay, I found my function at 3, and then I multiplied it by 2. So graphically, this means something different. We will not explore that, but when you come across a problem like this is how you approach it. So here are a couple of questions I want you to think about. Number 10, you have a function f. It is defined by f of x equals 2x plus 2. I've posed the question that if 4f of j equals 40, I want to find the value of f of 2j. I would like you to try this using what I have shown you and see if you can come up with the solution. I promise this will be the first thing we talk about after we grade homework on Thursday. The same thing for here. They want you to find the range this time for this equation if they give you this domain. This is not necessarily an f of x kind of question, but remember what you know about domain and range, and I want you to try this question. We will go over these at the beginning of class. I will see you guys tomorrow. Have a good evening.